This lesson is for Unit 2, Lesson 3 on the Pythagorean Theorem. So working with the Pythagorean Theorem, it's with specifically right triangles. So triangles that have a 90-degree angle, and you made a square on each of the three sides, then the largest square would be the exact same size as the two smaller squares put together. So for example, here's my right triangle. If I square this side, so I can see it has a length of 3. So if I square it, I'm going to have a total of 9. This length is a length of 4, so if I square it, it is now 16. And this last side has a length of 5. If I square it, it is now equivalent to 25. So the thing that's cool with the Pythagorean theorem is if I were to add the sum of the lengths of the two sides, the squares of those lengths, so 9 plus 16, it's going to equal the square of the hypotenuse side. So 9 plus 16 is a total of 25. That's the same as the square of the longest side, which also equaled 25. So from that diagram, we can derive a formula to use to determine the length of any of the sides of any right triangle. So a squared plus b squared equals c squared. So A and B are the legs of our triangle. So it doesn't matter which one is A and which one is B. If we square it, so A squared plus B squared, if we're saying that this is A and this is B, so A squared plus B squared is going to be equivalent to C squared. And C is always going to be the longest side, and we call that side the hypotenuse. It is always across from this right angle. Hypotenuse is always the longest side and always across from that right angle. So how we can use that equation, if we're given a triangle and we know that it's a right triangle, and we're given 2 of the 3 measurements, we can use that equation to figure out what the length of that last side is. So in this case, this length and this length are the legs of our triangle. That's what we're going to put in place of A and B. So it doesn't matter which one is which. We can say that 8 is A, so A squared plus 6 for B, so 6 squared, and that's going to equal C squared. 8 squared is actually 64. 6 squared, 6 times 6 is 36, equaling C squared. If you add those together, 64 plus 36, we end up with 100, equaling C squared. So then if we square root on both sides, we would end up with the square root of 100 equaling C. If we want simplified radical form, you could think of this, if you actually take the square root of 100 as being 10. So the length of that last side is C equals 10. As another example where we're not given the hypotenuse, but we're given the hypotenuse but not a leg, you're still going to use the equation the same way. 14 in place of A, so 14 squared. We don't know B, so plus B squared equals 50 squared. We just have to do a couple different steps here. So 14 squared comes out to 196 plus B squared equals 50 squared, which is 2500. And now we just subtract because we're trying to get B squared by itself. So subtracting 196 on each side, we're left with B squared equaling 2,304. And then lastly, if you take the square root of each side, you'll end up with B equal to 48. So the length of that leg is 48. And you can also use the Pythagorean theorem with word problems. So it helps with these to actually draw a picture. So in this case, an 11-foot ladder is leaning against a building, and the base of the ladder is 4 feet away from the building. How far up the building does the ladder touch the wall? So we have our 11-foot ladder, so that's going to lean against our wall, and I know it has to measure 4 feet away from the wall, and we're trying to figure out how high up on our wall it hits. So here is our triangle. The 11, since it's the longest side and it's across from our right angle, is our hypotenuse. So that's what we're going to put in for C. And the 4 we can put in for either A or B, because they both represent the legs. So 4 squared plus B squared equals 11 squared. 16 plus B squared equals 121. And if we subtract 16, we end up with B squared equaling 105. So if I take the square root on each side, we would have B equals, and since this one's not a perfect square, we can leave it as a radical. So the square root of 105, or we could approximate it to be approximately, so the square root of 105 is approximately 10.25 meters up the wall. So x would be about 10.25 meters.